Secondly, I am going to explain on the basis of transmission technology. On the basis of transmission technology, okay. On the basis of transmission technology, network is divided into three types. First type, WLANs, wireless LANs. I'll explain it. It is very easy. Second thing, system area networks. Okay, SAN. We call it as SAN, system area networks. This topic is very next level. Okay. Third thing, POLAN. POLAN. Passive optical local area network. Passive optical LAN. Okay. Wireless LAN, system area network, passive optical LAN. Okay. Now let me come to you one by one. Okay, it is classified into three types on the basis of transmission technology. Nothing but what technology they are using to transmit the data within their framework. Okay. First thing I explained was what was the first thing, man? Wireless LANs. Nothing wrong. You have three devices or two or three devices connected to your home router. It's nothing but wireless LAN. Okay. Two or three devices connected to a wireless access point. What is access point? Any place where network connectivity can be established is known as access point. Now, what is wireless access point? Anywhere where a wireless connectivity can be established as wireless access point. Okay, nothing but your router. Their router is setting. You are establishing your through radio. Keep remembering mind. Ethernet uses electrical pulses for transmission of data. Okay. Wi-Fi uses radio waves. Keep in mind. Okay, I'll teach you after some time. When I cover the first layer of OSI model, physical layer, there are explained physical medium, transmission medium. Okay, there I'll cover this radio waves and electrical pulses. I'll cover all of those. Okay. Keep in mind. For now, keep in mind. Wi-Fi uses radio waves. Ethernet uses electrical pulses to transfer the data. Now, your Wi-Fi broadband, your Wi-Fi router is a wireless access point. Okay, nothing but the local area network which uses wireless access point to connect two or three devices. Is WLANs. Okay. Example, your home router Wi-Fi. Okay. That's it. Second, very important. System area network. System. I'll write 2 points here, which are very, very important. You must study in interview. If they ask what is system area network, what is SAN? They are majorly called as SAN because most of the major companies use this SAN. Okay. A high performance low latency network. What is SAN? A high performance low latency network which is used to connect devices such as supercomputers or data centers or what was it? SCP? Okay, should I call it? No, I'll call. Okay, AI data training centers. High performance computing. Okay, we often call it as HPCs. High performance computing, AI data trainings. Okay, any computers, any devices which is doing this, they definitely use SAN. System area network, because this network is a very, very high performance network and very, very low latency. What is high performance? Very high speed. Okay, very high speed with minimal amount of errors. What is low latency? Okay, what is latency? First of all? Okay, the time it takes to reach from one device to other device. Okay, now the latency in common Ethernet is somewhere around 50 to 60 microseconds. 10 power minus 6 seconds. 50 to 60 microseconds. But this has 0.1 microsecond. 0.1. Where is 0.1? Where is 50? There's a huge difference. Okay? This is very low latency. Okay? You might got a question in your mind. What technology does it use such that it has very low latency? Because Ethernet has 56 microseconds. I have learned about Wi-Fi, which also has near this amount of latency. How 0.1 microsecond? Okay? It uses some technology called as InfiniBand. InfiniBand. If you go to Google and search this, you'll get this. Okay? But I explain it. What is InfiniBand? A high speed, low latency, same definition. A high speed, low latency protocol or technique used for very high transmission of data. Okay? Within the network. Okay? Now, how this technique works, how this protocol works, okay? How this technology works. Let me come in. It follows a very basic principle. Okay? Very. It skips CPUs and sorry. It skips CPU and OS. That's it. That's a simple thing it does. It doesn't go to CPU, it doesn't go to OS. Okay? ये खेल खेलता है memory to memory. It only plays memory to memory. Okay? It doesn't play CPU and OS. Passive optical local area network. Okay? A LAN which uses passive optical splitters. This is the definition of POLAN. Okay? Now, don't get confused. Okay? Here, first of all, what are the components used in this network? First thing is optical splitters. Second thing is optical line terminal called as OLT. Third thing is optical network terminal. Okay. Fourth thing is AND devices and Ethernet cables. Fifth thing is optical fiber. Okay. I'll explain you this with a diagram. You'll understand this very easily. What is passive optical local area network? And one more important point. This is used for point to multi-point connection. Just like a hub. I told hub. Okay. I told hub. It takes from one device. It just broadcast. It just send it to everyone. Okay. This also does the same. Point to multi-point. Okay. Passive optical LAN. Now, first of all, we have OLT here. What is optical line terminal? Optical line terminal. This is the brain of POLAN. Okay. This is the brain of POLAN, which does MAC checking, which just error checking. All these are done by this. Okay. Now, coming forward, it has something called as optical splitter. Okay. This is optical splitter. Now, why we are calling passive optical? Passive optical is nothing but it requires no energy. You remember I told you about passive hub and I told you about active hub. Active hub is nothing but which requires energy to amplify the signals. Passive hub is nothing but it doesn't require energy. It just simply sends data to all the ports. Okay, that is why this was a passive. It doesn't require energy. It is like a prism. Light comes, travels. Kind of that kind of thing. Okay. Optical splitter. Whenever this is optical fiber. Okay. Whenever the data comes to this optical fiber, it goes in these ways. Okay. Here we have optical network terminals. which then uses Ethernet cables. These are optical fibers only, okay? These are optical fibers, okay? These then uses Ethernet cables to connect to end devices, okay? We have optical network terminals, Ethernet, end devices. We have optical network terminal, end devices, Ethernet cables, end devices. Now, suppose when A wants to send the data to C, I'll explain the work. A creates a frame, destination MAC address, source MAC address, and user data, some user data which it wants to send to C. It goes to Ethernet through Ethernet. Now, optical network terminals has some sort of algorithm which work in as it does, okay? It converts Ethernet electrical signals to optical pulses, okay? Optical network terminal is responsible for converting Ethernet signals to optical pulses, which because optical fiber requires optical pulses to be transmitted, okay? Now it will go to this optical splitter, it will go to optical line terminal. Now this will check, this has a mapping routing table, okay? This has a routing table or switching table kind of thing. It will check, okay, destination MAC address is of C, then it will tell to the splitter, okay, you should go to here. It will add a special header. Such that because I told you it is a point to multi-point connection, the data will come here, but it will get split to all of them. This OLT adds a special header so that all the other things must reject this. Must reject what? The packet which has come from A. Okay? Only this should accept. It adds a special header. Now, optical network terminal of this optical network terminal of C takes this and again converts the optical pulses to electrical pulses or signals required by Ethernet. Again it will go to device C. From device C, the device C and IC will pick it up. It will convert it to bits. Finish. This is what happens. Okay.